You would think organisms that never leave home wouldn't be able to provide much insight into the big picture. But precisely because these snails don't travel far from where they're born, they're the perfect species to understanding the history of marine ecosystems. I'm Emily Lungman, and I study the evolution of these snails to learn more about the history of coastal ecosystems. These snails live in specific rocky shore habitats and don't move far from where they're born. As a result, the evolution of these snails over multiple generations provide a window into the past. To study this question, I set out on a West Coast road trip. At rocky headlands along the Pacific coast, I would head out to mussel beds whenever the tide was low in search of this specific snail species. After collecting snails, I would gather data on their size and shell shape. I chased the tide along the coast. And after going to 19 sites across California and Oregon, I packed the samples and shipped them back to Vermont, where I extracted their DNA and sent it off for sequencing. The present-day DNA of these snails tells us information you might never expect. A strand of DNA from a small creature found in modern-day California can tell us information about the effects of glaciers on coastal ecosystems. During the last glacial maximum, thousands of years ago, when the world was much cooler, species retreated south to escape glacial ice sheets and find livable environmental conditions. However, the DNA of these snails show that at least one small population must have remained further north. When conditions began to warm and the species range began to expand, the southern populations came into contact with the northern population. The DNA of snails currently living in Southern California contain unique elements that reflect that these populations are older and have been separated from their distant northern relatives for a very long time. The shape of the snail shells tell a similar story. The southern snails are rounder and have a shorter spire than their northern relatives. These findings highlight that historical events can have long-lasting effects on the structure of ecosystems. Knowing this information is important since these genetic differences can impact the ability of species to adapt to future climatic conditions.